No.
Wait, nobody had any questions on that? Everybody got all of those correct?
No.
Speak now or forever hold thy peace. Who's up there? Say it now.
Jax.
Really? Jack's the person who just did it this morning in class? I'm sorry. Yes, Jack, which one do you have a question on? I would have thought that you and Ava would have got together, finished your math, and still would have had like 8 hours before you got to 3 in the morning. Which one, Jack?
You could pick one.
Well, I could rather you pick. Well, Soph, you got one?
I need 10.
Wait, the answer, how to do it?
How to do it.
Oh, sure.
Oh, I got that one. No.
I'm gonna do it even though it's already done, I'll just show you. First of all, ladies and gents, here's the deal. Remember, graphing is, only as good as you are at graphing, and only as good as your lines are, only as good as the graph is, blah, blah, blah. Here we go, Jax, you know this is coming. Both of these linear equations are in what form, Jax? Don't say the cover-up form. What is it, Jax? Standard form. Standard form. Right. In which way you solve the standard form by finding Ava Russell? The mathematical term for this is finding the starts with intercepts, x and y intercepts. So for this first one, it crosses the x-axis. You cover up the y, and here's where people get all messed up. 3 times what number is 1?
3.
No. When you have 3x equals 1, how do you get rid of the 3 next to the x and solve for x? You have to divide by 3. The x-intercept is 1/3. So that's why this right here for this line crosses the x-axis at 1/3. Cover up the x, and y is 1. So there's those 2 points at which they drew this line. Second one is kind of the same. Cover up the x, and y is 3. Cover up the y, you get the same, well, x is 1, which is right there. So those are those 2 answers. Those lines are parallel and will not cross. Now, if you were not very accurate in your drawing and you missed a little bit, this one might be slanted a little this way and this one could go that way, and you might come up with something, but they're not supposed to. That is why, generally speaking, this is the beginning of linear equations and systems of equations. We don't really do a lot of solving by graphing, but it's good to know because, well, you're not special. So,
13.
13. Is that on my? It's recording. It's recording.
Yeah, it does. Top left.
You know what I miss? I miss COVID, tanks, staying home and pretending actually to do the stuff when you didn't really do anything.
I like that.
I missed that too.
I just left.
That's why we're in this predicament we're in, and we had 0 on the deal.
Awesome.
All right, ladies and gentlemen, when you're graphing lines, linear equations, when you come up with x's and y's, please, if it is just a single letter equal to a number, this is why you probably should look in your notes, because if it's x equals something, what type of line is it? Let's say it was x equal 2, no matter what is y equals 2, so if it's just x equal, this is going to give you a vertical line, a straight up and down line. If it is a y equal 1, no matter what x is, y is always -3. So find -3 on the y-axis, which is right here. And no matter what any of these numbers up here are, x is always going to be, or y is always going to be -3. So you can just keep putting a bunch of dots at where x, y is -3. That's your line. It is a horizontal line. And if you're doing the top one, again, Jax will tell you that that line is in standard form. Cover up the x, y is going to be -1. Cover up the y, x is +1. So the place they cross is right there. I'm just spending time drawing straight lines. Roland, could you be any more disinterested? Yes or no question?
Yeah.
Okay.
No.
What?
Yeah.
No, it's supposed to be no, I want.
No.
Wait, no, it's a yeah. It's supposed to be yeah. It's supposed to be yeah.
Russell, one more.
9.
9. Did we do 9 already? Again, a bunch of, both of these are in standard form. Ava, let's see which one you heard on. Let's do the top one. Ava, where does it cross the x-axis? If you cover up the y, 2x equals negative 12x's, negative 6. Which doesn't happen to be here, but it's gonna be right there because there's negative 5. Cover up the x and y is negative 4. Did you get that right? So those are those two lines right there. Other one, again, standard form, cover up the x, or cover up the y, x is negative 1. Cover up the x, y is, no, you have a negative and a negative. You have two negatives, so that's gonna make a positive one. So at that point, that's gonna give you that line, crossing right there. David, could you yawn any harder in my class?
Yeah.
Well, last one, Jax, I really can't, you could have asked me all this morning, if you didn't catch it. You and I were here, same time, like 30 minutes before anybody else. Which question?
You're 16.
16 on my sheet. 13, 14, 15, 16. Jax, what form are they on?
Standard.
Really? How do we solve standard, Jack? Find the intercepts. Let's be mathematical. Find the intercepts. If a first grader can understand the words that he was showing in that little primer, you can use mathematical words. Intercepts. Huh? Oh, so what you're saying is kids in the 1800s were much smarter than people are today. And that is truly a sad thing.
Teachers.
Yeah, maybe. Maybe it's because kids have video games now, stay up till 3 in the morning and don't care about their studies.
Yeah.
Anyways, Jax, look at the number 16. Cover up the y, what's x, Jax?
2.
No, that's not a 2, it's a negative 2. So here at negative 2, you put a dot. Cover up the y, or x, y is?
2.
No, there's a negative with the 2, negative 2. So there's that and that. There's this line. Bottom one. Cover up the y, x is, Jax?
Negative 3.
Where's the 3? So I covered up the y. X is,
Oh, it's a 1.
it is negative 6. So here it crosses right here. Cover up the x, y is, Jax?
2.
Positive 2, because there's two negatives. There you go, 2 lines, and they cross.
Alrighty.
Well, you're gonna ask me questions on the last 2 problems, right? Because when I give you quizzes that have really hard numbers that might take you a long time just to figure out. That's all right, I'm good. Here we go. Blank piece of paper, please. Blank, el blanco, el pizquetero. Remind me also to get back to these 6th grade quizzes, which many of you did very well on, and a few of you did not so well on. Some of you surprisingly did not do well on. Right on top of this paper, the little topic of today is called direct variation. Direct variation. Don't really need to emphasize that syllable or just write it down here. Direct variation. And with that being said, well, all right.
sure which way to give this to you.
Direct variation, the first thing is people will ask you for the equation of direct variation, so write this down. Write this down. Direct variation is y equals kx. Technically, no, that's not right. Y equals kx. Now, let's also be 8th grade mathematical students here. And if this is your equation, by the way, an example of this would be, let's say you get a job at McDonald's right now. Sam Patel, what would you suppose the hourly wage for McDonald's is? I don't know, but it's like 10 or 11 or 12 or whatever, okay? Okay, an example, McDonald's salary, ladies and gentlemen, is an example of direct variation. Okay, in the sense that if you worked at McDonald's, the number of hours you work equals the number of amount of money that you get. In other words, the more hours you work, the more money you get. Because there's such a thing as indirect variation, which would be the opposite of that, which would say the more you work, the fewer dollars you make, which doesn't make sense a lot of times, but there are some things that do work in indirect variation. For example, your gas mileage. Your gas mileage on a car is indirectly variable, an indirect variable to how fast you're going. The faster you drive a car, the lower your gas mileage is. That's just kind of the thing there. So there are some things that as one goes up, the other goes down. But in direct variation, it's as one goes up, so does the other. That's how most things work. Most things are direct variation. It is also really the same thing as being proportional. All these things are kind of related a little bit here. So let's just do this. If I put this in that McDonald's thing there, if I said y equals k times x, okay, x would be, okay, think about this. This is no more than kind of a glorified linear equation in the sense that, you know, if it's solved for y, x is the input number. I'm putting in how many hours I work. Would I say, let's say McDonald's worker makes $11 an hour. Okay, K is, K is my $11 an hour, and Y is how much money. It's the dependent variable because it depends on how many hours you work. You work 1 hour, you get $11. You work 3 hours, you get 33 schmaltz. You work 7 hours, you get $77, just that way. Okay. The letter K, because it does not change in all this, I keep multiplying by this 11 every time, is what's called the constant of variation. Constant because it does not change. Now, with that being said, this was the part where I was going to get at here. If you have y equals kx, I can rearrange all those numbers and make two other equations out of those. If I asked you to solve this for x, if I asked you to take this equation, solve it for x, what would x equal? Well, how would I get rid of the k in front of the x? I would, you're so good. Evan says I would divide by k, would I not? I take a line, put k here, and I put k there. So x equals what? Y divided by k. You're picking up what I'm laying down here? Because if this was your equation and you were solving for x, you would say, I'm going to divide this by k, I'm going to divide that by k, and that's what x equals. Poof! So much better having Evan right next to me because he focuses a lot when I get a lot of good answers. Now, this one I'm going to leave up to Ben Moon, because I know he's capable of this. Ben, I've solved this for y, I've solved this for x. If I want to solve this for the letter k, what then does k equal? What does k equal?
How many times that? Or would why do I wait?
Looking at the original equation here, to get the letter k by itself, what do I have to do to get rid of the x?
Divide.
Exactly. I would have to divide by x and divide by x. So k equals, Ben, k equals y
Over X.
over x. Okay. And they're gonna ask you if some things are examples of direct variation. For example, let's say I have 3, 6, I have 2, 4, and I have 10, 20. How would I know if those 3 points are an example of direct variation? Well, you could put them in a table, but I don't know if you'd even need to do that. But let's do it because Evan suggested it and it's not a bad idea. Here's x, here's y, right? I have 3, 6, I have 2, 4, and I have 10, 20. Those are my 3 points. Is that direct variation and why? The question is, does it have a constant of variation? Is the same number, do you multiply each time I do this, 3 times some number give me 6, 2 times some number give me 4, 10 times some number give me 20. Is that number the same for all of them? If it is, then it is direct variation. Is it?
Yeah.
Yeah. What is your constant of variation? 2. What would be your formula? Y would equal 2 times what k is. I'm sorry, what x is. I'm sorry. No, it's kind of a glorified way of something that you've already been doing. It's really not that terrible. Open your book to page 367 or 365. Was that not clear, Jack? I should probably put it, I had it before. For letter A, it says, is y minus 12 equals x? Is y minus 12 equal x? Is that an example of direct variation? Yay or nay? Raise your hand if you think it's yes. Come on, people. We just went over this. Let me tell you this for sure. Never with direct variation will you ever have pluses or minuses. It always has to be multiplication. Always. Thanks, Jack, for doing it just because so people can do that. How about this one? Y over negative 3 equals x. Direct variation or not? Now, to aid you in your thought process, if by chance you would go back to our previously scheduled note there, look at the 3 examples of what can be direct variation. Okay, k is always the number. Could you, which one of those, what was the number? Negative 3. Where was the negative 3? Was the negative 3 under the y? So that would be a form of direct variation in this form. So the answer to that one is Yippers. Okay, yes, it would be. By the way, you can manipulate this equation. How would I get rid of a negative 3? If I was solving this for y, I would multiply both sides by negative 3. So this would just use y equals negative 3x. Figure that out. How's about this one? Does 2xy equal 8? 2xy equal 8. would that be direct variation or not? Really, the best way to figure that out is solve for y. If I were solving that for y, what would it look like? I would first probably divide by 2, right? 8 divided by 2 is 4. X times y equals 4. If I'm getting rid of the x, I would have to do what, David? Divide by x, divide by x. Can direct variation be y equals 4 over x? Going back to our other equation, Deb, do you see any place where the constant is over x? Nope, nope, and nope. This would not be true. As a matter of fact, you could actually figure this out. If you made a table of this and just did this here, let's pick numbers. What could x be that you could divide by 4? You can't put 0 in there, right? Because that's not fun. You could divide by 1, you could divide by 2, and you could divide by 4, just for easiness. Okay, what is 4 divided by 1? 4. What is 4 divided by 2? 2. What is 4 divided by 4? 1. Remember, direct variation, as one goes up, so does the other. As x was going up, did y go up? Negative. What would you multiply these by to get the other one? What do you multiply 1 by to get 4? Does that work for this? 2 times 4? 4 times 4? No. So, not. I can tell you are mesmerized by this. I think it all started with the Ella Bowman comment. Did she be less disinterested? Ella! Direct variation or not? Now, it's always good to look at your notes at the 3 examples of direct variation. Was there ever an example in your note where the constant, which is the number, was there any place where y equaled y times k? Huh? Or is there a way I could change it so that it would be? What's that? All right, if I divided by 3, I get divide by 3. And I divided that by 3, I get y equals x over 3. Is there a case of y equals x over a constant? Let's go back and look. Y equals x over a constant. Now, wait, here is the last thing that you have to understand. What is another way to write this? Let me say y. Remember, you can always put a 1 in front of numbers. So this technically is the exact same thing as saying y equals 1/3 times x. Is this an example of direct variation? Yes, it is. Because what is your constant of proportionality? It is 1/3. You multiply everything by 1/3. That's exciting. Without any further ado, then, I'm stopping with that. Finally, from the book, your assignment. Your assignment is, did I not write it down? Problems 1 through 25 on lesson, write this down because it's been a while, 56. 56. I'm also going to give you back that 6th grade quiz that you took. Please do yourself a favor. If you've got something wrong, please figure out what it is. Please figure out what it is. Please, for the love of all that's good and right. Stop right there.